This is where we left off last time. We looked at the graph of the hyperbolic cosine of x, and this is the shape of it, and it doesn't fall below 1. Now, what we want to do is also look at, well, we looked at the hyperbolic sine of x before. So the next thing we're going to look at is the hyperbolic tangent of x. Let me clean some areas of the screen first of all. Now, as for the hyperbolic tangent, let me just copy the screenshot and place it here. So this is a screenshot that I generated in GeoGebra, alright, for the hyperbolic tangent. Now, as for the hyperbolic tangent, remember, tan, sometimes I like call it tansh, and I've seen online where somebody call it tan h, sin h and cos h, but let me call it tansh or tan for now. Tan x is equal to, now you remember what it was? It was sine x over cos x, which is e to the x minus e to the negative x over 2 divided by e to the x plus e to the negative x over 2. So if you multiply both of them, you have e to the x minus e to the negative x over 2 multiplied by 2 divided by e to the x plus e to the negative x, and the 2's cancel. So what you have is e to the x minus e to the negative x over e to the x plus e to the negative x. So this is e to the x minus e to the negative x divided by e to the x plus e to the negative x. So as long as you remember the sine of x and the cos of x, you can derive the tan or the tansh or tan h of x, the hyperbolic tangent. Now what does the graph look like? Well, this is what I had, right? Now let's look at GeoGebra. We had the cos hyperbolic cosine of x. Let's change it to tan. Oh, the key on my laptop is not working, so I'm using on-screen keyboard. The tansh or the tan of x looks like this. Alright, let's zoom in. So the tan of 0 is 0 based on what this is saying. The tan of 0.2 close to 0.2. We're going to look at these values. It seems to go up to 1. Well, not really, but it gets closer and closer to 1. So the curve, this line 1, x equal 1, seems to be an asymptote to the curve, right? We're getting closer and closer to 1, but never seem to reach it. If we zoom out a bit and consider what's happening below the x-axis, We seem to be getting closer and closer to -1, but we'll never reach it. All right? Now, let's look at this. Here, suppose we put in 0 for x. First, before we do that, let's look at what the calculator has to say. The tan of x, what is that going to be equal to? Tan of 0. Tan 0 equals 0. And then the tan of 1 equals 0.76. 2 if we round off to 3 decimal places. The tan, based on this, what is, it looks as if the tan of a half is, where's the half line now? I want to look at the half line and see what's going on here. The tan of 0.5 is a little below 0.5. It's not what I'm seeing here. So let's see. The hyperbolic tangent of 0.5 equal 0.46 something. Alright, agrees with the graph. Let's look at something here. Let's look at the exponent form, the exponent expression of tan x. Let's put 0 in it and see what would happen if we really would get 0. Oh, I'd put THAN because I keep saying tan. The tan H, hyperbolic tangent of 0. So we put 0 here is equal to e to the 0 minus e to negative 0 over e to the 0 plus e to negative 0 equal 1 minus 1 over 1 plus 1, which is 0, divided by 2, which is 0. Okay, good. That's 0. Let's say we have another value, 1. What would it be? Tan of 1 is equal to e to the 1 minus e to the negative 1 over e to the 1 plus e to the negative 1, which is e minus 1 over e divided by e plus 1 over e. Let's use our calculator and see what would happen in that case. So you have e minus 1 divided by e equals 2.350, all right, 2.350 divided by, I'm showing that I'm using 3 decimal places, that's why I put the 0 there, all right, and then we have, let's get rid of this one here, we have e to the e plus 1 over e, so e plus 1 divided by e equals 3.086. 3.086. Now we want to find out what, oh, wrong thing I opened a while ago. We want to find out what is 2.350 over 3.086. Let's see what would happen in that case. 2.35 divided by 3.086 equal 0.761. 0.761. Now, let us find the tan of 1 and see 0.761. So they agree. All right. Now, the thing is, we want to find out the tan of, this reaches 4, 5, let's say the tan of 5. What is tan 5? Let's just use your calculator. You could put in e to the 5 plus e to the negative 5 and so on. But let's use a calculator to find the tan of 5. That will give us point very close to 1. So it's getting very close to 1. Suppose we find the tan of 6, even closer to 1. What's the tan of 7? Even closer, getting closer. The tan of 10. Extremely close. Right? Tan 11 equals at some point, you know, the calculator will just round it off to 1. Tan 12, 1. Right? It's not really 1, you know, but it's just rounded off to 1. But as you move further to the right, you get close to 1. Suppose you say you want the tan of negative 5. You get negative 0.999 something. Alright? So you can see what's going on here. Now, what the shape of the graph is suggesting is that when you find the tan of an angle, it's not going to be 1 or larger. So here, when you find the tan of an angle, no matter what that angle is, it's not going to reach 1. Now, let us look at some inverse tan. Tan, my gosh, I did it again. Tan inverse of 0.999. Let's just use a calculator and see what is going to happen here. Tan inverse of 0.999. So tan inverse of 0.999 equal. Okay, good. What about the tan inverse of 0.999999 equal 11.8. Let's add a few more 9s to it. Equal 15 point that. Let's put some more 9s to it. Equal 29. So it's rising but slowly. But suppose we say we want the tan inverse of 1. What would it be? Undefined. The tan inverse of 1.1. Undefined. You cannot reach 1. You cannot touch 1. You can get close to it but not touch it. So let's look at a little thing here. Suppose you say the tan of an angle x is equal to 1. What would that angle be? What you would be saying is that e to the x minus e to the negative x, e to the x minus e to the negative x, all over e to the x plus e to the negative x is equal to 1. Let's see something. E to the x minus 1 over e to the x equals 1 multiplied by e to the x plus 1 over e to the x. We multiply by e to the x, we get e to the x all squared minus 1 is equal to e to the x all squared plus 1. Subtract e to the x squared minus e to the x squared is equal to 1 minus 1. 0 is 0. Alright. Now, suppose we consider this being a little more than 1. All of these ones, we're going to put them as 1.1 and see what will happen. 1.1. We just passed 1 a while ago. So, oh, it wasn't this one. This one is okay. I shouldn't interfere with these ones. It's 1 over e to the x. 1 over e to the x. This is okay, but here we multiply this by 1.1. 1.1. Now, this is saying 1.1 e squared, e to the x squared minus 1 when we multiply by e to the x. Let's not multiply by e to the x yet. Let's erase this part and continue down. This is e to the x minus 1 over e to the x is equal to 1.1 e to the x plus 1.1 over e to the x. Let's multiply by e to the x now. This is e to the x. It will multiply by itself, so it's squared minus 1 is equal to, this is multiplied by e to the x, so 1.1 e to the x squared plus e to the x will cancel itself here, so it's 1.1. So we have e to the x, let's subtract, minus 1.1 e to the x squared is equal to, add 1 to both sides, 1.1 plus 1. Now, this is, oh, this is squared, you know. Yeah, e to the x squared minus 1.1 e to the x squared is equal to, add 1 to both sides, 1 plus this 1.1 here. Now, 1 minus 1.1. So we're going to get a negative 0.1. Negative 0.1 e to the x squared. Negative 0.1 e to the x squared is equal to 2.1. And e to the x squared is equal to 2.1 divided by negative 1.1. No, it's divided by 0.1. It will be 21, negative 21. Now, here, you square something and it's negative 21. How is that possible? Let me see something here. E to the x. When you square that, you get negative 2.1. If you consider e to the x to be any number, say 5, when you square 5, you get a positive value. Alright. If you have negative 5 and you square negative 5, you also get a positive value. When you square a number, you're never going to get a negative value. Right? That's one thing. Not only that, if you try to find e to the x, what is e to the x? You square root both sides. You're trying to find the square root of a negative 21. Right? Still wouldn't work. At least we're talking about imaginary numbers. Suppose you ln both sides. So you have ln e to the x squared equal ln negative 21. This is 2 ln e to the x. Oh, look at this. You see ln e to the x is the same as ln e to the 2x is equal to ln negative 21. So it's 2x ln e. What ln e is 1. So it's 2x is equal to ln of negative 21. But the problem is, you cannot find the logarithm of a negative number. For similar reasoning that we spoke about up here, right? So here now, if you square any number, the answer will not be negative. So this wouldn't work. So here, this is undefined, right? So if you find the tangent of an angle, it's not going to go above 1.1. That's why the graph cuts off close to 1. It doesn't even reach 1, so it's not going to pass 1 and go above it. Same thing with negative 1. It doesn't reach down to negative 1, so it's not going to pass negative 1 and go lower. Alright? So you're not going to be able to find the hyperbolic tan of an angle such that the answer is 1 or greater or negative 1 or smaller. It ranges between, well, it's greater than negative 1 and less than 1. That's a range of values of the hyperbolic tangent of any angle. And that's why the graph has this shape.